Okay. Could you please recall the formulas? Because this is the chapter 24. We studied 3 important formulas. Am I right? What are the formulas, my dear? Not 3, 4. Potential energy, electric potential energy, U, which is equal to K Q1 Q2 over R. Am I right? Am I right or not?
Yes.
Yes, good.
And then potential V, which is equal to K Q over R. And you have general formula for this potential, work done divided by the unit charge. Actually, the main formula is this. How we got this? We got this formula by substituting the value of work done. You got this rule. Am I right? And then we studied the work done. What is the formula for work done? Work done, which is equal to charge multiplied by its change in potential. If you want to move charge from one place to another, for example, we got this from here. V, which is equal to W over Q or Q naught. Therefore, Q, which is equal to, work done, which is equal to Q multiplied by V. V is nothing but potential or change in potential. Both are exactly the correct. Clear? And then we studied the relation connecting electrical field and potential, which is nothing but dV over dr. So by using these formulas, we are going to solve 5 questions. And out of this, second question is very, very important. It's exactly same like your chapter number 22. I think chapter number 22, 16 or 19. I don't know the number of the problem, but it's related with a square shape. So today also we have one question related with the same type of problem. So please listen the problems very carefully, my dear. It's one of the important topic, and it is considered for your quiz too. And also in the final exam, some question will be coming from this chapter. Clear? Clear, my dear?
Clear that.
Yes. Okay. Read the question. What is given in the question? A charge conducting sphere of radius 5.5 centimeter set up potential. So that means you have the conducting sphere. That means charge conducting sphere. That means what is the meaning for conductor, my dear? The charges will be exactly sitting on the surface of the conducting sphere. Am I right? So you have the conducting sphere and its radius is given. What is its radius, my dear? What is its radius? The radius is 5.5. The radius of the sphere is 5.5 centimeter. So you have to convert it to meter. And it set up a potential of 75 volt at a radial distance of 2.2 meter. That means at a distance of 2.2 meter from the surface to the distance of 2.2 meter, how much voltage it produced? It produced 75 volt. So what is the distance here? The distance is clearly mentioned as 2.2 meter. So consider at infinity your potential is 0, because generally whenever you are moving away from the charge particle, your field strength will be 0, your potential will be 0, there will be no charge. Clear? So according to the question, when you read the first line, you have the charge sphere and its radius is 5.5 centimeter and it set up 75 voltage at a distance of 2.2 meter. That means the radial distance. Clear? Now what you are going to do, we are going to find what is the potential on the sphere surface. So that means if you have any charge on the surface, what should be the potential? We have to find this value. So that means you have two potential, you have two distance. The first distance, the radial distance, means from the center to here is 2.2 meter. So I am going to name, this is my V1, this is my R1, and this is my R2, this is my V2. Am I right? Because if you have any charge on the conducting sphere, the distance from the center is nothing but its radius. Am I right? Am I right or not?
Yes.
Okay, so we have to use this formula because this question is related with the potential. So I am going to apply this rule for each and every distance. So first I am going to apply the rule for this distance and voltage, and second I am going to apply the rule for these two, potential and radius. So I am going to apply for the first one. So what you will get, my dear? V, which is equal to, that means V1, which is equal to K Q over R1. Am I right? So this is my first equation. And second equation, if I just apply the same rule for this, I will get V2, which is equal to KQ over R2. So this is my second equation. Now, the main thing, we are going to find the value of V2. So I am going to divide the equation 2 by equation 1. So divide equation 2 by 1. So left hand side divide separately, right hand side you divide separately. So left hand side, if you divide, what will get, my dear? V2 over V1, which is equal to KQ over R2 divided by KQ over R1. Am I right? If you expanded this equation, what you'll get? This becomes KQ over R2 multiply with R1 divided by KQ. Am I right? Am I right or not?
Yes, you are.
So this KQ get cancelled. So left hand side I have V2 over V1, which is equal to R1 over R2. My dear, please take your calculator. I need the answer from your side. Don't give the answer from the slides. Please work out by yourself and please let me know the answer now, because I am also going to work out here. I want to check my answer. Okay, so we are going to find the value of V2. Therefore, my V2, which is equal to V1 multiplied by R1 over R2. Am I right? Am I right or not? Am I right or not?
Yes.
Yes.
So what is the
Yes,
value
yes.
of V1? V1 is already given in the question, which is nothing but 75 volt, and R1 is given in the question as 2.2 meter, but your R2, it is in centimeter. That means what is the centimeter? 5.5 centimeter. So if you convert it to meter, 5.5 multiplied by 10 to the power of minus 2. Could you please tell me the answer, my dear?
3,000.
75 multiplied by 2.2 divided by 5.5 10 to the power of minus 2. So I got exactly 3000. So I can write 3 multiplied by 10 to the power of 3. Am I right? Volt. So this is the answer for the first question. But you have another also. You have two questions in this problem. Am I right? So second question, you have to find what is the surface charge density. My dear, what is surface charge density? So this is your part A. What is your second part? Surface charge density. What is the rule? Surface charge density you already studied, sigma. What is the rule? Surface charge density Q, which is equal to, sigma, which is equal to Q over area. Am I right? So without Q, because area we already know, because the formula for the area, what is the surface area of the sphere? The surface area of the sphere is 4 pi r square. So no problem. But if you want to work out this rule, you need the charge. Am I right, my dear? Am I right or not?
Yes.
So what I am going to do, my dear, here you have two rules. Am I right? Here you have two rules. Am I right? Rule number 1 and rule number 2. Am I right?
Yes.
Am I right or not? Choose any one, because you can see in equation 1 also I have Q, in equation 2 also I have Q. That means both charges are exactly the same. Am I right? Only the distance is different. But what is the charge? So the charge will be the same. So if you want to work out with the first equation or second equation, you will get the same answer. So, but in this, I am going to use the second equation. If you want to use the first equation, no problem. Go ahead. You will get the same answer. So for getting the charge, so I have to need the charge. So I'm going to take the second equation. What is my second equation, my dear? V2, which is equal to KQ over R2. Am I right? So my value, so I have to rearrange this equation first in terms of Q. Therefore, Q, which is equal to V2 R2 over K. What is V2? It is already given in the question, 75. And what is your R2 value? 2 point.
V2 is 3,000.
Oh, sorry. V2 is 3000. Sorry. By mistake, I take V1. Okay, if you want to take V1, no problem. That will also give the same answer. So better I can write the V2. What is V2? 3000. 3 multiplied by 10 to the power of 3 multiplied by R2. What is the value of R2?
2.2.
What is the value of R2, my dear?
Yes, sir.
2.2.
5.5 centimeter. Am I right?
Yes, yes.
So 5.5 multiplied by 10 to the power of minus 2 divided by k is the constant. 8.99 multiplied by 10 to the power of 9. So if you just work out what you'll get, my dear, please let me know the answer. 3 10 to the power of 3 multiplied by 5.5 10 to the power of minus 2 divided by 8.99 10 to the power of 9. So I got 1.835. Am I right? 1.835 10 to the power of minus 8, and the unit is coulomb. So now I got the rule, or I got the value of Q. Now I am going to take this Q value, I am going to substitute here, and I am going to take this A value, I am going to substitute here. So what you will get, my dear? So better I can just work out here itself. So what you will get? Sigma, which is equal to, what is the value of Q? 1.835 10 to the power of minus 8 divided by 4 multiplied by pi multiplied by my radius, because it's a surface area of the sphere. So radius is nothing but 5.5 10 to the power of minus 2 the whole square. So when you just substitute the value, so what you'll get? 1.835 10 to the power of minus 8 divided by 4 multiplied by pi multiplied by 5.5 10 to the power of minus 2 the whole square. So I got 4.827 multiplied by 10 to the power of minus 7. Did you got the same answer? Did you got the same answer, my dear?
Yes, doctor.
Okay, what is the unit for the surface area? Q over A. What is the unit for charge? Coulomb. What is the
Coulomb.
unit for the area? Meter square. So this will be the answer for this question. Clear? Clear, my dear?
Yes.
Yes.
Do you have any doubt in this question? If you have any doubt, please ask me. First of all, please, my dear, every time read the question, first you bring the diagram. When you just draw the diagram based on the information, it will be very easy to solve. Clear? Okay,
Clear.
next we come for the second question. Second question, it's very, very important, and at the same time, if you think properly, this question is nothing. It's very easy. Again, it is exactly same like a 4 charges. So read the question. What is given in this question? 7 charge particles. 7 charge particle. What are the charge? You can see the picture. How many charge particles are here, my dear? How many charge particles are here? See the red color. 1, 2, 3, 4, 5, 6, 7. So I have 7 charge particles are fixed in the place to form the square with an edge length of 5 centimeter. That means what is this 5 centimeter?
Length.
Each side will be exactly 5 centimeter.
5 centimeters.
That means this side, this side, this side, everything will be same 5 centimeter. Clear? So that value is given. Now what you are going to do, you are going to bring some charges from infinite distance. What charge you are going to bring? You bring plus 6e charge from infinite to the center. That means you have, for example, my dear, listen carefully, you have 6e charge at infinite. For example, you consider this is your infinite distance. In this place, you have 6e charge. What is the charge? 6e charge you have. That means the value of the charge is 6e. You initially have this 6e charge at infinite distance. Now what you are going to do, your objective, you are going to take this charge and you are going to bring the charge from infinite to the center of the square. Clear? Clear, my dear?
Yes.
So if you want to bring the charge from infinite to the distance, what you have to do? You have to do some work done. Am I right? Without work done, it will not possible. Am I right or not? So you have to do some work. So why we have to do work? Because here already you have 7 charges. So the interaction will be there from this charge. So you have to do some positive work, otherwise it will not happen. So what I am going to do, my dear, for the easiest purpose, I am going to divide these 7 charges into 2 types. What are they? For example, if you see the picture, I have 4 charges in the corner. Am I right? What are the corner charge? 1, 2, 3, 4. These 4 are the corner charge. Am I right? Am I right or not?
Yes.
And I have 3 charges middle. What are the middle charge? What are the middle charge? I have
-2 plus 2
plus 3. So I can just name the number. For example, if these are 4, so this is my 5, this is my 6 and 7. Am I right? So what are the corner charge, my dear? My corner charge, my corner C-O-R-N-E-R, corner charge. What are the number? Corner charges are 1, 2, 3 and 4. My middle charge is, what are the middle charge? 5, 6, 7. Am I right? Clear?
Yes.
Okay. Now what I am going to do, first I am going to work out for the corner charge. I am going to find the potential, because they clearly mention you have to find the work done. What is the formula for work done, my dear? My formula for work done is work done, which is equal to charge multiplied by my potential. Am I right? Am I right or not? So if you want to get the work done, first you have to find the potential. What potential? The potential based on the corner as well as the potential based on the middle. That means my potential here, which is nothing but potential for the corner charges plus potential for the middle charge. Am I right? So first I am going to find the potential for the corner charges. So we know the formula for the potential. What is the formula for the potential? KQ over R. So what is the distance of the corner charge? My dear, listen carefully. From this charge, that means this is my distance to the center, and this is my distance to the center, and this is my distance to the center, and this is my distance to the center. That means for the corner charge, this will be the distance. Am I right? Am I right or not?
Yes.
Am I right or not? So once you know the diagonal, if you divide the diagonal by 2, you will get the information about this R. Like your chapter number 22. Go to your chapter number 22. I explain how to find the value of R. Clear, my dear? That's one of the important thing, because in this chapter, when you just work out with the corner charge, your corner charge R is diagonal divided by 2. Once you find the diagonal, you will get the information about the R. But for the middle charge, what is the distance? But for the middle charge, what is the distance, my dear? This is the distance. Am I right?
Yes.
Am I right? Am I right or not?
Yes. Yes.
2.5.
Ah, very good. So the middle charge distance is clearly mentioned, because the edge length is given as 5. So what is the half of the 5? Is exactly 2.5.
2.5 centimeter.
Sorry, centimeter, not meter, centimeter. Clear, my dear? Do you know the difference between the corner and the middle? Corner charge distance from the center to the concerned charge is diagonal divided by 2. But for the middle charge, it's exactly the edge length divided by 2. Clear?
Yes, doctor.
Edge length divided by 2. Clear? Okay. Let's be finished for the corner charge. What is the formula? Potential for the corner charge. So I have 4 charges. I'm going to use this charge for each and everything. So K Q over R1 plus K Q over R2 plus K Q3 over R3 plus K Q4 over R4. Am I right? Am I right or not? Am I right or not?
This is what, doctor?
This is for corner. So I'm going to write the potential only for the corner. Okay, that means K Q1, Q2, this is Q3, Q4. What is Q1 charge, my dear? What is the value of Q1?
-E.
Okay, now you can see for the corner charge, your R is exactly the same. Am I right? Your R is exactly the same. Am I right?
Yes.
So I can just exactly write R value. That is very good. It's very easy. No need to write like this. Otherwise, you will get confused. So better I can write R. So what is the value of R for each? R. So K over R is the common term. So I can take it out. So what is inside? Inside I have only charges. Could you please tell me what is the value of Q1? My value of Q1 is minus E. What is the value of Q2? What is the value of Q2?
3E.
Minus 3E. What is the value of Q3? Plus E. What is the value of Q4? Plus 3E.
Plus
What
3E.
happened, my dear? Plus 3E
0.
minus 3 cancel. This will be get cancelled. So what will be happen?
0.
0. So
0.
don't worry about the R value. Clear? Because here anything multiplied by 0 is 0. Am I right? Even though if you have the
Yes.
value for R, even though if you have the value for K, if you multiply anything with 0 is 0. So no issue. Clear?
Clear.
Understand? Okay.
Yes,
Now
doctor.
let's we come for the middle charge. What is our middle charge? My V middle, which is equal to K Q5 over R plus K Q6 over R plus K Q7 over R. Am I right? So I can just write the formula like that. Again, because each for the middle atom, my value of R is 2.5. It's the same value. So I can take the K over R outside. Clear? So what is inside? Could you please tell me the charge value of Q5? What is the value of Q5?
Minus
2E.
2E.
Minus 2E. Q6 plus 2E.
Plus 2E.
Plus
And then
2E.
Plus
Q7
the 3E.
plus 3E. Am I right? Now you can see plus 2E minus 2E is cancelled. And finally what I got? So I got the middle potential, which is equal to K multiplied by 3E divided by R. Am I right?
Yes.
Am I right or not?
Yes.
Okay. Now I have to find the value of potential, because here I wrote the formula. What is the potential value, my dear? Change in potential, which is nothing but corner potential plus middle potential. Am I right? So I can just find the net potential. My net potential, which is equal to V middle plus V corner. My V middle has K 3E over R. My corner has 0. So anything with add with 0 is exactly the same value. So my change in potential is K multiplied by 3E over R. Clear? Clear, my dear?
Yes.
Okay, now we have to find the value of work done. So you have to bring this 6E charge from infinity. So here I'm going to use this rule. So if you just use this rule, what will happen? If you use this rule, what will happen, my dear? My work done, which is equal to Q multiplied by delta V, and here my Q is nothing but 6E charge. Am I right? Am I right or not?
Yes.
Right or not?
Plus 6.
And what is my potential? What is my potential here? Multiply by K multiply by 3E divided by R. Now, could you please multiply in the top numerator? 6 multiplied by 3 is 18. E multiplied by E is E square, and K divided by R. Now substitute the value. It will be easier for you. Okay, my dear. Now you substitute, because if you substitute initially, you will get some complication. So better, I'm going to substitute the value at the last. So 18, and the value of the charge is a constant 1.6 10 to the power of minus 19 the whole square, and K is also a constant 8.99 multiplied by 10 to the power of 9 divided by my R value. What is the value of R for the middle? It's exactly 2.5. Am I right? So 2.5 10 to the power of minus 2 the whole square. Am I right? Am I right or not?
Yes.
Without a
Okay,
square.
now substitute the value. Use the calculator and please let me know the answer. Yes, my dear.
Without square.
Ah, sorry. Without square. Sorry. Okay, I made a mistake. Okay, now tell me the answer.
Why you talk, doctor, only the middle?
Because your corner is get 0. Your corner, anything multiplied by 0 with this R is 0. Am I right?
Yes.
Am I right or not? So you will get the R value only for the middle. For example, my dear, here corner atom diagonal. You can just see, I already written here. If you want to get, for suppose, if your middle gets 0, corner gets some value. What is your R? First you find the diagonal and then divide by 2, you will get the R. But unfortunately, our charge get cancel each other. So my corner gets 0. Am I right or not? My corner potential is get 0. Am I right? So I have only the R for the middle. So middle distance is 2.5 multiplied by 10 to the power of minus 2. Clear?
Yes, Doctor.
Okay, tell me the answer. I'm waiting for your answer. Don't tell my answer, my dear.
1
Use your
second, Doctor.
calculator and please tell me the answer.
Just 1 second. Doctor, on the bottom, 2.5 multiplied by 10.
10 power minus 2. Because it's a centimeter. You have to convert it to meter.
1.65.
Very good. I also got the same thing. 1.657. Am I right?
Yes, multiplied by 10.
1.6757 multiplied by 10 to the power of minus 25.
Yes.
What's the unit for the work? Joules.
Joule.
Clear?
Yes.
Clear? So, my dear, this is one of the important question in chapter number 24. So, please, if this type of charges will be given, first you have to separate the corner, second you have to separate the middle, and then add both. Add what answer you got, just add both, then your answer will be easy. Clear?
Doctor, for
Understand?
the Q, is it given plus 6e?
My dear, K value, E value, everything will be given. So don't worry.
Doctor,
Clear? Yes.
I have a question.
Yes, please.
Suppose if the diagonal is not 0, if we have to bring a value, we need to use Pythagoras
Yes,
theorem
you have to
here,
bring the value. So what you have to do, my dear, listen carefully. How to find the diagonal? I told you to go back to chapter number 22. Am I right?
Yes.
In
Yes,
the chapter number
Pythagoras.
22, I already solved one question. Better I can just open the slides. Now you will get some clear idea. Suppose if your diagonal will not get 0, suppose your corner atom will not get 0, what you have to do? I will tell you. I will just show you that what happened to this. I already explained this problem. Am I right? Am I right or
Yes.
not?
Yes, you explained.
Here I teach you how to find the R value. Am I right?
Yes.
You can see here. You can see here. I teach you how to find the R value. So you have to find the R. You have to take the Pythagoras theorem, and then because it's exactly same like square. So if your corner charges will not get 0, then you have to work out. So I don't want to repeat these things. I already taught this information in chapter number 22. Am I right? So go
Yes.
back to chapter number 22, get the answer. But unfortunately, this corner will get 0, so no issue. But in the exam, if the corner value will be given, you have to find the R value like this. Clear?
Yes.
Clear, my dear?
Yes, it's okay.
Okay. Okay. Let's just go to the third question. Third question is very easy. Don't miss this type of question. Okay, my dear. Question wise, maybe it will be seems like very big, but answer wise, it is very easy. Read the question. What is given in the question? When an electron moves from A to B, my dear, first of all, please see the diagram. You can see I have the orange color dotted line. That means I have two equipotential surface. This is my equipotential surface 1. This is my equipotential surface 2. Clear? Understand? Understand?
Yes.
And then I have blue color lines, and all these lines are my electrical field lines. Now I took 3 points. 1 point from equipotential surface 1, that is nothing but A, and I took 2 points on equipotential surface 2, which is nothing but B and C. We already studied, my dear, if you want to move the charge from one surface to another surface, you will get the work done. Am I right? Am I right or not?
Yes.
If you want to move the charges on the same surface, what should be your potential? What should be your work done?
0.
0. We already studied this in the theory. So if you want to move the charges in only one surface from one point to another point on the same surface, your work done will be 0. But if you want to move the charges from one surface to another surface, you will get some value. So that information today we are going to work done. My dear, listen carefully. When an electron moves from point A to B, that means the electron is moving from point A to B. And by the time, how much work done you did? How much work you did?
4.78.
4.7. So work done by moving the electron from point A to B, which is equal to 4.78 multiplied by 10 to the power of minus 19 joules. And now you have to find what is the potential from B to A. That means A to B or B to A, both are same. So you are going to move the charge, move the electron from A to B. They clearly mentioned. So what is the potential difference from moving the charge from A to B? What is the potential difference? Moving the charge from A to B should be right like this, which is equal to, what is the formula? We know the formula, work done, which is equal to charge multiplied by delta V. Am I right? Am I right or not? So this is nothing but my delta V. Am I right? So my delta V, which is equal to work done by charge. Am I right?
Yes.
So work done by charge. My dear, now the most important thing. My dear, you are moving the charges from A to B, but your field lines are opposite to the direction. So what should be your angle? You are moving the charge from here, but your field direction is this direction. So what should be your angle?
0.
How it is 0? If it is moving on the same direction, it is 0. If it is both are moving in the opposite direction, what should be your angle?
180.
180.
180. So cosine of 180, because we have the formula work done, which is nothing but FD cosine theta. So FD cosine 180 becomes negative. Am I right? So what type of work you have? Negative work. Am I right?
Yes, yes.
Yes.
And also you are moving the electron. So what is the value of the electron? It is negative 1.6. Am I right? 10 to the power of minus 19.
Yes.
Am I right or not? So I have to write minus 4.78 multiplied by 10 to the power of minus 19 divided by my electron charge value is negative of 1.6 multiplied by 10 to the power of minus 19. So when you just work out what answer, this negative get cancelled with each other. So what should be your answer, my dear?
Why the
4.78?
why negative?
My dear, what?
The charge. Why negative? Why?
Here, what is this?
Electron.
What is the value of electron? Positive or negative?
Okay, thank you.
That's what I put negative. Clear? So when you just work out what answer you will get, I will get the change in potential from A to B, which is nothing but, what is the value? 2.98 the unit, because this is a potential. So my answer will be B. Understand? Clear? Yes.
And the question they said the electron move from A to B, but in the
Yes, of course.
but in the figure from B to A.
My dear, don't get confused, my dear. Actually, you can write VA minus VB or VB minus VA. Both will be give the same answer. Understand? Clear?
Yes.
Understand? Because both are exactly representing delta V.
Okay.
Clear?
Yes.
Both will be the same, my dear. Don't get confused by yourself, because your potential is a scalar quantity. It is not a vector quantity. We already studied. Am I right? So
Yes.
VA minus VB or VB minus VA, both will be the same. Clear?
Again,
Yes.
please, why did you put minus W?
My dear, you are moving the charge from point A to B. Am I right?
Yes.
But your electrical field lines are this direction. See the arrow mark. My arrow mark, black color line is my moving this direction. My electrical field will be in this direction. So what should be your angle?
It will be minus.
180 degree. So it is negative value. That's what we put negative.
Okay.
Clear? Okay. Let's we come for second question. What is your second question, my dear? Tell me the second question. VC minus VA, which is equal to, again, negative of work done over negative of charge. Am I right, my dear? You can see here VA VB and VA VC. You can see both will be give the same answer. Am I right?
Yes.
Am I right or not?
Yeah.
So what will be the answer for the B question?
Exactly
2.98.
Exactly the same, because both distance are exactly the same. On the same surface, each point will have the same value. Am I right?
Yes.
Whether VB or VC, both are exactly the same according to the picture, because we already studied in the theory. Same, each and every point on the same surface will get the same value. This point, this point, this point will get the same value. So here, according to the picture, my VB exactly equal to VC. Am I right?
Yes, you are.
That's what I am using the same answer as A. Clear? Clear?
Yes.
Clear.
Okay. Now you have to tell me the answer for the last one. What is the answer for last one?
0 because it's the same
VC,
surface.
0.
VC minus VB. What is the answer, my dear?
0.
What is 0? Just tell me clearly. What is 0?
The work done.
The work done.
If work done, because you are moving the charge from B to C. I already told you, if you want to move the charges from one point to another point on the same surface, what should be your work done?
0.
0.
So 0 divided by any charge value is nothing but
0.
0.
0. That's it. Clear?
Yes.
Clear, my dear?
Clear, Doctor.
Clear.
Okay. Shall I go to the fourth question?
Yes.
Yes.
Okay. Read the question. In the figure, calculate the net electric potential at point P. That means if you just see the picture, I have 4 charges: charge 1, charge 2, charge 3, and charge 4. And all these charges are separated with some distance. What is the, for example, this is our point P. So now what you are going to do, at this point P, you are going to calculate what is your V. Clear? Clear, my dear? So you have 4 charges, and each charges have some distance to the point P. Now, if you consider the point P, what should be the net potential at the point P with these 4 charges? So again, I have to deal with the same formula, V, which is equal to KQ over R, where R is the distance. So, but what is the distance here? What is the distance here?
D.
D. So, according to this picture, my R is exactly equal to D. Clear? Understand?
Yes.
Okay. Now, I am going to write the net potential. My net potential, which is equal to V1 plus V2 plus V3 plus V4. Am I right? Am I right? So I am going to apply this rule for each and every one. So what you will get, my dear? K, Q1. What is the distance between this P and Q1? What is the distance? D. Clear? Understand? Plus K, Q2 over, what is the Q2 distance?
D.
D. Very good. What is the distance of V3? Sorry, 3.
D.
So K, Q3 over D. But what is the distance of Q4 from point P?
2D.
2D.
Very good. K, Q4 over 2D. Understand, my dear? Understand?
Yes,
Yes.
Doctor.
Okay. Now, but you can see all the charges have the same value. What is the value of all charge? So according to the question, my Q1, which is equal to Q2, which is equal to Q3, which is equal to Q4, which is equal to Q, which has the value of 7.5 femtocoulomb. What is the meaning for femto? 10 to the power of minus 50. Clear? So now what I am going to do, I am going to take the common term outside. If you just see this equation, my K value is the common term, so I take it outside. Clear? So, but in the denominator, you can see here D, here D, here D, but here I have 2D. So I can take the LCM for 2D. Clear, my dear? If you want to get 2D, what you have to multiply?
2.
Clear? So what you will get here? You will get 2Q. Am I right?
2Q1.
Q, because Q1, Q2, Q3, which is equal to Q, I already written here.
Yes, but Doctor, the charge is different.
How the charge is different? You can see here what is mentioned here.
Yeah, but I mean, some of them positive and some of them negative.
My dear, value sign doesn't matter. What is the value of the charge?
Yes, okay.
because I will not change the sign, because whatever the sign you get in the picture, I'm going to write it here. So you can see here, better we can change the sign here. My Q1 is positive, Q2 is positive. What is my Q3? What is my Q3?
Negative.
Negative.
Negative. What is my Q4?
Negative.
Negative.
Okay, better I can change it here. Okay. Clear? Okay. Now,
Yes.
if you want to get a 2D, again I have to multiply here. Here I have to multiply by 2. So what will be the answer, my dear? Here it is 2Q. Am I right?
Yes.
Okay. Again, if I want to get 2D, I have to multiply by 2 here. Also, I have to multiply by 2 here. So what will be the answer? Minus 2Q. Am I right? And already here I have 2D. So multiply by 1. Here also multiply by 1. So what will be the answer, my dear?
Q.
Clear? Clear?
Yes.
So now plus Q get cancelled with minus Q. What is remaining, my dear? 2Q minus Q. What is the value?
Plus Q.
Plus Q. So divided by 2D. Now substitute the value. K value 8.99 multiplied by 10 to the power of minus plus 9. Multiply by, what is the value of charge? 7.5 multiplied by 10 to the power of minus 15. Divide by 2 multiplied by, what is the distance here? The distance is already given as 1.6 centimeter. So 10 to the power of minus 2. Clear? Understand? Just tell me the answer. Just tell me the answer. What's the answer, my dear? 8.99 10 to the power of 9 multiplied by 7.5 10 to the power of minus 15 divided by 2 multiplied by 1.6 10 to the power of minus 2. So I got a 2.107. Did you got the answer?
Yes.
10 to the power of
Yes.
minus 3 and the potential unit is V. This is the answer for the fourth question. Clear?
Clear.
Okay. Now, last question of this chapter, but it's very easier chapter, but you have to use the formula. Question wise, it will be seems like very big, but answer wise, it is nothing. You have to recall the formula. My dear, here you have infinite conducting sheet. What is the electrical field for infinite conducting sheet, plane sheet? We already studied in chapter number 23. What is the rule, my dear? Conducting sheet, plane sheet. Electrical field E is equal to sigma over. Did we study this rule? Chapter number 23, Gauss law.
Yes.
Just give me some response. I'm asking you the question. We studied two formulas in chapter number 23. One is for plane sheet, another one for conductors. For conductor E, which is equal to sigma over epsilon naught. Am I right?
Yes.
Am I right or not?
Yes, right.
Yes.
So here what is given here? So the first formula is applicable for this question. They clearly mention it is an infinite non-conducting sheet. It is only one sheet. With a uniform surface charge density, set up a parallel equipotential surface. So you have equipotential surface, which is nothing but parallel, and any pair of surface differing by 25 voltage. That means its change in potential is given. What is that value, my dear? What is the value?
25.
That means you have the potential. So the change in potential between the two surfaces is exactly 25 volt. And how much these two surfaces are separated? The two surfaces are separated as
8.8 millimeter.
8.8 millimeter. So if you convert it to meter, 8.8 multiplied by 10 to the power of minus 3 meter. So you have two equipotential surface, but one sheet producing so these two surfaces have the change in potential 25 volt, and the distance between the two surfaces is exactly 8.8 millimeter. Clear? Now what you are going to do, find, my dear, you are going to find what is the magnitude of the surface charge density. My dear, could you please recall the rule? Because we have to find the electrical field, they clearly meant, so we have to find the sigma. So if you want to find the sigma, could you please rearrange this equation? Therefore, sigma, which is equal to electrical field multiplied by 2 times of epsilon naught. Am I right? Am I right or not?
Yes.
But is there any information about the electrical field?
No.
So what we have to do? We have to use the relation. What is the relation? Electrical field E, which is equal to minus dV over dx. We studied this rule. Am I right? Am I right or not? Minus dV
Yes.
over dr we studied, but here we just consider for only one dimension. So we studied this rule, minus dV over dr. Am I right? So r is the position vector. So I just consider for only one axis. That means one dimensional point of view. So if I just want to write this equation in terms of one dimensional point of view, I can replace this r with
X.
x. Okay, now substitute the value. Minus of, what is my dV? 25 divided by, what is my dx? 8.8 multiplied by 10 to the power of minus 3. Could you please tell me the answer of my electrical field? My answer for the electrical field is nothing but 25 divided by 8.8 10 to the power of minus 3. I got
Minus 2,840.
minus 2,840.9. What is the unit for this electrical field? Newton per Coulomb. Am I right?
No.
Now, after I
Yes.
got this value, I am going to take this value. I am going to substitute this. When you substitute, what you will get? Minus 2840.9 multiplied by 2 multiplied by the constant value epsilon naught. What is the value of the constant value? Which is nothing but 8.85, which will be given in your exam. So don't worry. 10 to the power of minus 12. So substitute the value. Multiply by 8.85. 10 to the power of minus 12 multiplied by 2.
Minus
So
5.
I got 5.028. Am I right? 5.028 multiplied by 10 to the power of minus 8. What is the unit for this? The unit for this, Coulomb per meter square. Am I right? Am I right or
Minus
not?
5.
Sorry, minus. I forgot to write the minus. Okay, minus. Clear? So this will be the answer for the first question. Any doubt for the first question? Any doubt?
No.
Okay. Could you please tell me the answer for the second one? What is given in the second one, my dear? It's a theory question. If an electron is released near the sheet, does it tend to move from higher to lower or vice versa? That means, my dear, if you just see the plate, I have two plates, one plate with a positive charge, another plate with a negative charge. Okay. Now, if I put the electron, what will happen? What will happen?
It will be attracted.
All the times, if you put the electron, all the times the electron, for example, this is my higher potential, this is my lower potential. Am I right? Am I right or not?
Yes.
If you put the electron, all the times the electron is moving from lower potential to higher potential. If you put the positive proton, your proton will be always moving from higher potential to lower potential. Now, could you please tell me the answer? Here, according to the question, they mentioned the electron. If you put the electron from one plate, where it will be moving? Lower to higher or higher to lower? Just tell me the answer.
Lower to higher.
That will be the answer for the B. Clear?
Clear.
Clear, my dear? Lower potential to higher potential. Understand?
Yes.
Yes.
That's it. Chapter 24 is over. So your quiz portions are ready. Inshallah, by next week, you are going to write the quiz 2. Am I right? So, my dear, listen carefully. Quiz 2 portion. What are the quiz 2 portion? Chapter number 22, 23, 24. Which day you are going to write? Which week you are going to write?
Next week, Monday.
That means 11th week is your next week. And which day?
Monday.
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 Which period?
8.
Because Monday you have period number 8. Am I right? What's the
How
time?
many questions actually?
My dear, I will tell you this information inshallah by next week, because next week Sunday you have the class. Am I right? So I will tell you how many questions I put, but I will not give the answer question. Understand? I will tell you the number of questions. Clear? Okay, what's the time? 8th period. 2 p.m. to 40 minutes you are going to write. So these are all the information about your quiz 2. Inshallah, I will tell you the number of questions by next week. But my dear, listen, prepare everything from the slide. My question from the slide, because the slides is prepared on based on the syllabus. Clear? Understand?
Yes,
Understand.
doctor. Doctor,
That's it. Yes.
do you have office hour after this class?
Yes, of course. I have office hour by 3 o'clock, by 2 o'clock, inshallah.
Okay. Thank you, doctor.
Okay. Okay, my dear. Now I have to close this. I have to open the chapter because still we have 40 minutes. Am I right? Am I right or not?
Yes, you're right.
Why no answer from that side? Sleeping, huh? Okay. So, brother, this chapter is very easy. It's a very, very easier chapter. But please, my dear, listen carefully. You have many formulas. So, the title of today's chapter, chapter number 25, capacitance. That means we are going to study the concept of capacitor. So, if you are studying the concept of capacitor, from that you will get the information about what is capacitance. So, what are the topic today we are going to discuss? We are going to study the definition, what is capacitor, and then what is the rule for the capacitance of the capacitor, what are the factors which will be affecting the capacitance of the capacitor, because it's a 1 mark theory question. My dear, this topic is related with the theoretical part, and also this is also related with theoretical part. And then we are going to find what is the capacitance of the parallel plate capacitor. My dear, listen carefully. I will ask you the question because in this chapter we are going to substitute the formula from the previous chapter. Clear? Understand? So I need the answer from your side. So you have to open your mouth and you have to give the answer. Clear? Understand?
Understand.
Okay, good. And then we are going to study the concept of energy stored in the capacitor, because last week you did the discharge of the capacitor. What is capacitor? In the capacitor you can store some charges. That means if you want to store some charges, you are going to store some energy. Am I right? So we have two formulas from this topic, and then we are going to study the energy density. My dear, don't get confused about energy and energy density. Energy should indicate it with the letter capital U, but the energy density should indicate it with the small u. Clear? Clear, my dear? Energy density is small u, energy capital U. And then we are going to study the concept of dielectric capacitor. That means we are going to study the concept of dielectric. If you are using the dielectric in the capacitor, then the capacitor will be called as dielectric capacitor. And finally, we are going to study, for example, this is the practical applications. If you connected many capacitors in parallel way, if you connected many capacitors in series way, what will be your answer? So we have two equations, and in this chapter we have two problems based on the capacitance in parallel and capacitance in series. Clear? And finally, we are going to conclude the session with cylindrical capacitor. So please, my dear, this topic is nothing. I will finish this topic very quickly, but you have to cooperate with me, because I will ask you a question from the previous chapter, because we are going to use many formula from the previous chapter. So please listen carefully. So these are all the types of capacitor. We have more capacitor, but here I posted some picture because we have ceramic capacitor, we have electrolytic capacitor, we have the variable capacitors, many things we have. We have dielectric capacitor, we have cylindrical, so many types of capacitors we have in our day-to-day life. And we have the application of these capacitors in our day-to-day life. Clear? So we are going to study this. So what is the purpose of these devices, my dear? In this device, you can store some charges. What is the main application of this device? In this device, you can store some charges. Clear, my dear? Understand?
Clear, doctor.
So one needle is for using positive charge, another one is for negative charge. That means you are going to take two needles with, that means two polarity will be there. One is for storing positive, another for negative. And some capacitors will be different, but here the concept, we are going to store some charges. Let's start with the first slide. What is given in the first slide? The definition for the capacitor. What is capacitor? It's a 1 mark theory question. The capacitor is a device that stores electric charge Usually on the conducting parallel plates. You can see in physics, we have to use this symbol for capacitor. So what you observe from this capacitor, my dear, you have two lines parallel to each other. Each line is a conducting plate. Each line is a plate. So how many plates you have here? How many plates you have here?
2.
That means plate number 1 is this, plate number 2 is this. And these two plates are separate with some distance. You can see these two plates are not joined together. These two plates are putting with some distance. So you can see it is not joined together. We have to place these two conducting plates with some distance. My dear, the most important thing, the distance is one of the parameter. So you have to make a small distance. Why small distance? Because if you make too big distance, what will happen? The field strength will be weaker, because we already studied in chapter number 22. Whenever you are moving away from the charge, what will happen? Your field get weaker. Am I right? So when you maintain the distance in case of capacitor, you have to maintain the small distance. Clear? Inshallah, we are going to study the factors affecting the capacitance of the capacitor. By the time you will get the clear information. Understand, my dear? Okay. Let's we come for the capacitance of the capacitor. My dear, the capacitance of the capacitor should be given by the formula C, which is equal to Q over V. C is the capacitance of the capacitor, where Q is the charge stored on the capacitor, and V is the voltage across the capacitor. My dear, this is one of the important rule, and we are going to use this rule in many cases. Understand? Understand, my dear? So C, which is equal to Q over V, where C is the capacitance, which is equal to Q over V. My dear, if you want to get one capacitance, what you will do? If you want to get one capacitance, what you will do?
Divide by 2.
I want to get one capacitance value. In this place, I want to get one capacitance. That means 1 farad I want to get. If you want to get 1 farad, because the unit for the capacitance of the capacitor is farad. Suppose if I want to get 1 farad, what you will get? What you will get? Use the formula. What is this?
Q over V.
What is Q?
The temperature,
Current.
the charge stored.
My dear, what happened to you? Who says current? Huh? Are you in the class? Are you in the class, my dear? We finished chapter, maybe after 21 chapter, we are right now, we are in 25th chapter. Now you are saying Q is the current. What is this?
I don't say current, doctor.
No, I am not saying about you, Mr. Abdullah. Somebody they say current.
Sorry.
I know your voice. My dear, C is the capacitance, Q is the charge. Because in the capacitor, you can store some charge. So what is the unit for charge?
Coulomb.
Coulomb. So if you want to get 1 farad, how much charge you have to take? 1 coulomb of charge you have to take. Right?
1 coulomb over 1 voltage.
Very good. So if you want to get 1 farad, you have to substitute 1 coulomb of charge over 1 volt. You will get 1 farad. So this is the rule for the capacitance of the capacitor. Clear, my dear? It's a one more theory question. Clear. Define 1 farad. Suppose if you are asking the question, define 1 farad. So please write this. You will get the answer. Okay, you will get the full mark. 1 farad, which is equal to 1 coulomb of charge over 1 voltage, which gives you 1 farad. Clear? Clear, my dear?
Clear.
Clear.
Okay. Now,
clear.
this slide is very, very important, because it's from this slide we will get some theory question. My dear, I don't know about your midterm exam. Sorry, I don't know about your final exam, because midterm exam is in the online mode. We already completed, but we don't know about the clear picture about your final, whether it is online or campus. We don't know. But if it is in the campus, you have to write something on the paper. So in such a case, this slide is very, very important. Suppose if you take a capacitor, what is capacitor? We use the capacitor to store some charges. Am I right? Am I right or not?
Yes.
So if you want to store some charges, sometimes some capacitors you can store more charges. Some capacitors you can store only small quantity of the charges. So these 4 parameters, which will be affecting the capacitance of the capacitor. Suppose if you want to store more charges, the first point, the shape and the size. My dear, the shape of the plate, because capacitor, I already told you, it should be indicated with a symbol like this. Am I right? So this plate, maybe it is a circular in shape or square in shape or rectangular in shape, no issue. So if you have the shape, if the size of the plate is more, you can store more charges. Am I right? Am I right or not? If the plate will be smaller, you can store only small charge, small quantity of the charge. Suppose if the plate is more, suppose if the plate is big size, how many charges you can store? You can store more charges, am I right?
More.
And also the shape, different shape,
Yes.
circular shape, square shape, rectangular shape. So each shape will have some different area, am I right? Am I right or not?
Yes.
Yes, doctor.
So if the area is big, you can store more charge. If the area is small,
Small charge.
few quantity of charges you can store. Okay, let's come for the third point. The separation between the plates. My dear, this distance is very, very important. Just before I told you. So if you maintain the distance too big, what will happen? The electrical field between the two plates, because one plate is completely positive, one plate is completely negative. So if you have positive and negative, you have the field strength like this. Am I right or not? You have the electrical field lines like this. Am I right? Am I right or not?
Yes, doctor.
Yes,
Yes.
doctor.
So if
Yes,
the
next.
distance will be great, if the distance will be greater, your field strength will be weaker, and finally, what will happen? My dear, could you please turn off your mics? Actually, I hear more noises. Could you please turn off your mic? If I ask you the question, please open your mic and give your answer. After that, please turn off your mic. Clear?
Clear, doctor.
Yes, doctor.
Okay. Now the distance, if the distance will be large, then you can store only small quantity of the charge, because you are weaker, your electrical field will be get weaker. So in such a case, you cannot be able to store more charge. So when you design any capacitor, the distance between the two plates must be smaller. When the distance will be smaller, you can store more. If the distance will be larger, you can store less. And finally, the dielectric substance. Actually, this dielectric substance is a insulating material. What is this? The dielectric substance is always an insulating material. My dear, listen carefully. This is the capacitor picture. Both plates are separated with some distance. When you place a dielectric material between these two plates, what will happen? It will increase the efficiency of the capacitor. When you place an insulating dielectric material in between the two plates of the capacitor, it will increase the efficiency of the storage. Clear? What storage? The charge storage. Understand, my dear?
Yes, doctor.
So 4 point, shape and size depends on the charge storage. Surface area is also depend on the charge storage. And the distance between the two plates is very, very important. Shorter the distance, charge quantity will be more. Greater the distance, charge quantity will be less. And finally, when you place any dielectric substance, any dielectric insulating material between these two plates, it will increase the efficiency of the charge storage. So these 4 parameters depends the capacitor will depends on these 4 parameters. If you maintain these 4 parameters properly, you can store more charge. Clear? Clear, my dear?
Doctor, could you please explain the second point again?
The second point is the area. My dear, actually your plate will be like this. You can see here. Actually, this is my first plate. This is my second plate. And these two plates are separate with a distance d. Now what is this? This is the area of the first plate. So here you can store positive charge. Am I right? And this is my second plate area. You can store negative charge. Am I right? So if the area will be smaller, you can store only small quantity of the charge. If the area will be big, more charge. Logically you can think, if the area is big, you can make many people to sit. Am I right? If the area is small,
Yes.
Only few people.
Less people.
Am I right? So likewise, here people is nothing but our charge. If the plate size will be more, if the area will be more, you can make many charges to come and sit on the plate. Clear?
Yes, thank you.
Okay.
But
Now,
the distance d between them must be smaller.
must be smaller, because if the distance will be greater, then the electrical field strength will get weaker, because both charges will be separated with more distance. What will happen? The electrical field lines will be weaker. Clear? So maintain the distance smaller, maintain the area bigger, so you will increase the efficiency of the capacitor.
Yes, doctor.
Okay. Now, capacitance of the parallel plate capacitor. My dear, listen carefully. We are using many formulas. The main thing, we have to get this formula. This is the final formula. What is the capacitance of the parallel plate capacitor? This is the rule. The final answer is epsilon naught multiplied by area divided by the distance between the two plates. So we have to get this rule. How we got this rule? That explanation is given here. My dear, listen carefully. If you take a conducting, because it's a conducting plate, if it is a conducting plate, what is our electrical field formula, my dear? The conducting plate's electrical field is sigma over epsilon naught. We already studied in chapter number 23. Am I right? Am I right or not?
Yes.
And what is sigma? My sigma, which is nothing but charge over area. Am I right? We already studied this rule. Surface charge density. Am I right?
Yes.
Take this, substitute here. If you substitute here, what you will get? Your equation will be like this. Am I right? Am I right?
Yes.
Okay. Now you have two plates, plate number 1 and plate number 2. So here you can store positive charge. Here you can store negative charge. Am I right? Am I right or not?
Yes, doctor.
Okay. If you have positive and negative, you will get the electrical field lines. Am I right? So how you can find the the potential, that means voltage across the two plates. My dear, if you want to find the voltage across these two plates, what you have to do? Voltage, which is equal to electrical field multiplied by its distance. What is the electrical field? It is between the positive plate and the negative plate. And what is the distance between the two plates? It is d. So if you want to find the potential, electrical field multiplied by distance is the potential. So I got this rule. Am I right? Am I right or not? Clear?
Clear.
Okay. Now, after I got the potential, I am going to take this E. I am going to substitute here. If you substitute, your equation will be like this. Am I right? Am I right
Yes,
or not?
doctor.
Okay. Now, what is the formula for capacitance of the capacitor? We know capacitance of the capacitor, which is equal to Q over V. Am I right?
Yes.
Am I right or not? Okay. Now, listen carefully, my dear. I am going to take this V, because V, delta V, both are exactly the same. Clear? So I am going to take this V. I am going to substitute here. What will happen? Your equation will be like this. Am I right? Am I right? Am I right or not?
Yes, you're right.
So now Q get cancelled with this Q, and this is D over epsilon naught A. So if you just in terms of multiplication, this will go to the numerator, this D will come to the denominator. Finally, you will get this equation as C, which is equal to epsilon naught A over D. Am I right? Clear? Clear?
Clear. Yes.
Okay. So this is one of the important formula we are going to use in the numerical question. My dear, don't forget about this rule. This rule is very, very important. If you know this rule, the dielectric concept will be very easy, because last topic of this chapter is dielectric. If you know this rule, only small change. I will tell you what is the change. Okay. Now let's come for calculating the energy. So my dear, listen carefully. Initially, you can see the picture. You can see the picture. This is our capacitor and this is our battery. This is our battery. This is our capacitor. Clear? Clear, my dear?
Yes. Yes.
Okay. Initially, before you connect this battery with this plate, What are the charges present in this plate, my dear? Is there any charges will be there?
No.
No. That means if there is no charges means no energy. Am I right? Am I right
Yes.
or not? If there is no energy means there is no work
Yes,
done.
you're
Am I
right,
right?
doctor.
There is
Yes.
no energy, there is no
Yes.
work done. So, my dear, listen carefully. Initial condition. What is the work done on the plate? It is 0. Am I right?
0. Yes, you are right.
Okay. Finally, after you connect the battery with this plate, what will happen? Charge will go and sit on this plate. Am I right? Am I right?
Yes, you are right. Of course, doctor.
Okay. Now, finally, what is the rule? My work done, which is equal to charge multiplied by potential. We already studied this rule in the previous chapter. Am I right?
Yes, doctor.
Okay. Now, my dear, listen carefully. What is the net work done? What is the total work done? Or net work done? My initial
input,
value plus
the
final
initial.
value divided by 2. Am I right?
Yes, doctor.
So what you will get? 0 plus, better I can write capital Q because that will make sense. I can erase this Q, I can make capital Q. Both are exactly the same, but I can compare the information with the slides. So work done, which is nothing but Q multiplied by V. Clear? Now, Q multiplied by V divided by 2. This is my net work done. Am I right? So what will be the final answer?
Doctor, this
Yes.
is not like the average work done here.
Average, yeah, exactly average. Your total
Average.
of work done is nothing but here I am talking about the average. Better I can.
Okay.
Here the total represented the average. Clear? So
Yes,
QV
clear.
over 2. Clear? So work done is nothing but QV over 2. My dear, listen carefully. Work done, which is equal to QV over 2. What is my energy? My energy is also QV over 2.
Yeah.
Am I right?
I mean, yeah, you are right.
Because if you do some work, you can store some energy. Without work done, how you can store the energy? It is not possible. So I can directly write my work done, which is nothing but my energy. Clear? Understand?
Clear.
Okay.
Understand.
Now listen, my dear. I just write this equation twice a time. I will tell you why. So my energy, which is equal to QV over 2. Okay. Now, could you please tell me what is the equation for the capacitance of the capacitor?
Q over
Capacitance of
V.
the capacitor C, which is
Q
equal
over
to
V. Q over
Q
V.
over V. Therefore, my Q, which is equal to
CV. Yeah.
okay. Take this Q, substitute here. What you will get, my dear?
CV square of
Clear? So this is the first rule. Okay. Again, I am going to use the same capacitance of the rule C, which is equal to Q over V. I am going to write this equation in terms of V. Therefore, V, which is equal to
Q over
V,
C.
which is
Q over C.
okay. Now take this V, substitute here. What will happen, my dear?
Q square
Q square over 2C.
over 2C.
So how many formulas you have for the energy storage?
2.
That formula is written here. Clear?
Clear.
Understand?
Doctor.
Because in the you can see this box, the energy stored is exactly equal to work done. Whatever the work done, you are just putting on the plate, which is nothing but you are just storing the charge on the plate. So that means the charge has some energy. So we can say my work done is exactly equal to the energy stored in the plate. Clear? So understand, my dear, you have two formulas for the energy store. My dear, in the question, you can use any one of the formula. It's depend upon the given. Suppose if the question, you have the capacitance value and the voltage, you can use this. Suppose if the question have the charge and the capacitance, you can use this. But both equation will give you the same answer. Understand? Clear?
Yes, clear.
Okay. Now we come for the energy density. Just before I told you, my dear, energy should be indicated with the letter capital U, but your energy density should be indicated with the letter
U.
What is this? Small u. Okay, my dear, caps U, energy. Small u, energy density. Keep this information in your mind. Okay, understand?
Okay. Understand,
Okay.
Doctor.
So what is the definition for energy density? The definition for energy density is energy stored divided by its volume, because the plate has some volume. Am I right? Am I right or not? In this volume,
Yes,
how
you are
many energy you can store? In this quantity of the volume, how many energy you have to store? So how you can write the volume? I can write the volume in terms of area multiplied by distance. Am I right? I can write this volume in terms of.
Yes, Doctor.
So I can write this. This is the volume. Okay, don't get confused. This is the volume. So my volume is written as area multiplied by D. So what you'll get, my dear? You will get this. Now we have two formula for the energy. So what I am going to do? We have two formula. I can choose this rule in this place. So I am going to substitute U, which is equal to CV square over 2. So substitute here. What will happen? Your equation will be like this. Am I right? Am I right?
Yes, you are right.
Okay. Now this is related with the parallel plate capacitor. What is the formula for parallel plate capacitor? C, which is equal to epsilon naught A divided by D. Am I right? Am I right or not?
Yes.
What is this? Parallel plate capacitor formula. So what I am going to do, I am going to use this formula. I am going to substitute the formula here. If you substitute the formula, your formula will be like this. Am I right? Am I right?
Yes.
Now you can see area get cancelled with the area. What is remaining, my dear? My energy density. I'm sorry about this line, my dear. I'm extremely sorry. Even I was irritated with this line. Sorry. This is C, which is equal to D, and here your equation will be like this. Now my energy density, which is equal to, what is remaining? Epsilon naught 2 multiplied by V square D multiplied by D. It is nothing but D square. Am I right? Am I right or not?
Yes.
Okay.
Yes.
Now I can write this V square over D square as epsilon naught over 2 V over D the whole square. I can write like this. Am I right?
Doctor.
Yes. Yes, my dear.
Doctor. Your mic disturbs.
My dear, I don't have anything here, my dear. Actually, I don't place any electronic
No,
devices
Abdullah.
near to my system. What about others?
Clear, Doctor, clear.
No, it's
My dear
okay.
Abdullah, could you please turn off your mic and then on?
Okay, Doctor.
Is my voice is clear? Is my voice is clear now?
Sorry, I will. Yes, Doctor. I will refresh, Doctor.
Okay, now listen. So I can write V square over D square as V over D the whole square. Am I right? Now, my dear, we studied the electrical field. What is the formula for the potential? The potential, which is equal to electrical field multiplied by distance. Just before we studied this rule. Am I right? Therefore, my electrical field, which is equal to
V over D.
Okay, now you can see what we have here. Here also I have V over D. So how I can write this? I can write this as epsilon naught E square over 2. Am I right?
Yes.
Am I right or not? So, brother, you have two formulas for the energy density. What are the two formula? The first formula is energy per volume, or energy density, which is equal to epsilon naught E square over 2. Clear? Clear?
Clear, Doctor.
Yes, clear.
Okay. Now, my dear, this topic is very, very important. Please, my dear, listen carefully. So if you have n number of capacitor 1, 2, 3, 4, 5, 6, likewise if you have n number of capacitor, please, my dear, remember only two information. If you remember the two information, then this topic is nothing. So what I am going to do, I am going to take the capacitor. You can see I just put some picture here. How many capacitors I have here? Capacitor 1, 2, 3, 4, 5. Am I right? Am I right or not? You can see how many needles will be in the capacitor terminals. Terminal 1 is this, terminal 2 is this. Am I right? Am I right or not?
Yes.
How many terminals here? 1, 2, 1, 2, 1, 2, 1, 2. Am I right? My dear, if you connected all the first terminal together, if you connected all the second terminal together, then you have to say my capacitors are connected in why no answer?
Parallel.
Parallel. Very good. So if you connected all the first terminal together, if you connected all the second terminal of the capacitor together, then you have to say my capacitors are connected in parallel. So in such a way only we can differentiate. My dear, listen carefully. I am going to explain in this slide. I am going to take three capacitors for the explanation. Capacitor 1, capacitor 1, capacitor 2, capacitor 3. Clear? Clear, my dear? And all this, for example, this is my first terminal, this is my second terminal, this is my first, this is my second, this is my first, this is my second. What I told you, I have to connect all the first terminal together. Am I right? Am I right or not?
Yes. Yes.
And likewise, I have to connect all the second terminal together. Am I right? Now I have to connect these with a battery. This with a battery. Now, my dear, listen carefully. I am explaining the concept of capacitors in parallel. Keep these two information. What is the first information? So this is my C1, that means capacitor 1. This is my capacitor 2. This is my capacitor 3, and this is my battery. So in case of parallel, the charges will be different, but the potential will be the same. That means my potential is exactly the same. What is the meaning for potential? My V1, which is equal to V2, which is equal to V3, which is equal to V. That means potential across this capacitor is V1. The potential across this capacitor is V2. The potential across this capacitor is V3. All these V1, V2, V3 are exactly the same in case of parallel. Keep this point. This is the first point. Clear? Understand? Understand?
Yes. Yes, Victor.
And the charges you are stored in the capacitor 1, capacitor 2, capacitor 3 will be different. So potential will be same, but your charges will be same potential, but charges will be
Different.
different. Keep these two information, remaining or nothing. So what is your charge? My charge, which is equal to Q1 plus Q2 plus Q3, because all these three charges are different. That means the charges stored in the first capacitor will be different from second capacitor charge, will be different from third capacitor charge. Clear, my dear? Understand?
Yes,
Understand?
Victor.
Okay. Now tell me, what is the formula for capacitance of the capacitor? Just before we studied capacitance of the capacitor, which is equal to
C
Q
equals
over V.
Q
Am I right?
over- Yes.
Okay, now what I am going to do, I am going to substitute the charge value here. I am going to substitute the value of V here. So what you will get? My equivalent, my final capacitance. That means combination of how many capacitors I have here? 3 capacitors I have here. Am I right? So
3, yes.
the combination of all these 3 capacitors as taken as the final capacitance. That means this is C total. So C total, which is equal to, what is your Q here? Q1 over V1 plus Q2 over V2 plus Q3 over V3. Am I right? Am I right or not?
Yes, you are.
Okay, now in this place, I can write the charge total divided by the potential, which is equal to Q1 over V1 plus Q2 over V2 plus Q3 over V3. Am I right? Am I right or not? Am
Yes.
I right or not? Now, my dear, my V1 which is equal to V2 which is equal to V3, what will happen? This potential and this potential will be get cancelled. Again, you will get the same relation. Because if you put V1 which is equal to V2 which is equal to V3, this V and this V get cancelled, and finally you will get this relation. Am I right? Am I right or not?
Yes. Yes.
But in terms of capacitance, my capacitance, so because this is equal to my total capacitance, which is equal to, what will happen? This is my capacitance 1, this is my capacitance 2, this is my capacitance 3. Suppose if I have 5 capacitance, what will be the rule? C1 plus C2 plus C3 plus C4 plus C5. So if you take n number of capacitors in parallel, so what you have, how you can write? My n number of capacitors, C total, which is equal to C1 plus C2 up to Cn. Understand? Clear?
Yes, doctor.
Okay. So this is for capacitance in parallel. This is the rule. Don't forget about this rule. This is our rule. Okay. Now, when you come for capacitance in series, you can see here, see this picture, my dear. I have positive terminal, I have negative terminal. So the positive of the first capacitor should be connected to the negative of the second terminal. So the positive of the second capacitor will be connected to the negative of the third capacitor. If you connected the capacitor like this, then you have to say my capacitors are in series. Clear? Now you find the difference between the parallel and series. In parallel, what you did, all the first terminal will be connected. That means all positive connected together, all negative connected together. But what happened here? What happened here? First positive
and
should be
negative.
connected to the second negative. Second positive should be connected to the third negative, and the third positive should be connected to the fourth negative. Likewise, if you connect it like this, you have to say your capacitors in series. Now, I told you 2 points. Am I right? What are the 2 points? In parallel, you have same potential, but your charges is
Different.
what will be happen here? What will happen here? It's a reverse. It's a reverse. Same charge, but different potential. So if you know the information about the parallel, it's a reverse of the series. Now you can see I have the total charge Q1 which is equal to Q2 which is equal to Q3 which is equal to Q. So all the charges will be the same. But what is my potential? My potential B which is equal to V1 plus V2 plus V3. Now you can see here, my dear, left hand side I have the charge, right hand side I have the capacitance of the capacitor. This Q will get cancelled. For example, my C which is equal to Q over C1 plus, sorry, Q over C equivalent, which is equal to Q over C1, Q over C2 plus Q over C3. Now what will happen, my dear? Now what will happen? Just tell me. All this Q get cancelled. Am I right? Because I told you same charges. But what is your potential? Your potential 1 over C is nothing but your equivalent capacitor. So if you have the capacitors in series, then you have to write my C total or C equivalent, which is equal to how many capacitors you have. You have to write in terms of this type. Okay, my dear, do you get my point?
Yes, doctor.
Clear? But please keep this information in your mind. If you know this information, then the remaining thing will be easy. So if you want to write the equation, how you have to write? You have to write my C parallel is the summation of all the capacitor, but my capacitors in series is nothing but the inverse of the capacitor. Clear? Clear, my dear?
Yes.
Okay, I will stop up to this. Inshallah, tomorrow I will cover these 2 topics. Clear? Understand?
Yes. Thank you,
Clear,
Doctor.
Doctor.
Okay, my dear. Inshallah, if you have any doubts, you can just come exactly around 2 o'clock. So by the time I can just open the other discussion room. So now you can leave. I'm going to quit from this classroom, and don't forget about your quiz too. Clear? Understand?
Okay, Doctor.
Understand. Thank you, Doctor.
Okay, brother. Assalamu alaikum.
Wa alaikum assalam.